Ever pondered how rescue robots could become more efficient, perform better, and save more lives? The answer might lie in edge computing. But what is edge computing, you may ask? Simply put, it's a decentralized computing framework. Unlike traditional methods that send data across long distances to a cloud or a data center for processing, edge computing does things a bit differently. It brings computation and data storage closer to the devices where it's being gathered, rather than relying on a central location that can be miles away. This means data can be processed near the source where it's generated, reducing latency and allowing faster responses. It's a bit like having a local library in your neighborhood rather than having to travel miles to the central library in the city. Understanding edge computing is the first step. Now let's delve into how it enhances the performance of rescue robots. Imagine two rescue missions. One uses traditional rescue robots, the other employs robots powered by edge computing. What's the difference? In the first scenario, traditional rescue robots are deployed. These machines are often hampered by slow response times, limited coordination, and frequent connectivity failures, especially in disaster-stricken areas where communication infrastructure may be compromised. Now let's consider the second scenario. Here we have rescue robots enhanced with edge computing. These robots are able to process data locally, right where it's being generated, rather than relying on a distant cloud server. This means they can respond faster, coordinate better, and maintain functionality even when connectivity is sporadic or non-existent. Imagine a collapsed building scenario. Traditional robots might struggle to communicate, delaying rescue efforts. In contrast, edge computing robots can share real-time data amongst themselves, swiftly identifying the safest paths and potential survivors, all without dependence on a far-off data center. Clearly, edge computing's power to process data locally can significantly boost the performance of rescue robots. Designing a swarm of rescue robots using edge computing requires careful consideration. What should we keep in mind? First and foremost, robust connectivity is paramount. These robots need to communicate effectively with each other and the edge computing network to perform their tasks. Next, we must enable autonomous decision-making. In the chaos of a disaster, there's no time for a central control unit to micromanage every robot. That's where edge computing shines. It allows each robot to process data and make decisions on the spot, enhancing their efficiency and responsiveness. Lastly, we need to design these robots for scalability and resilience. Disasters can strike anywhere, anytime, and our rescue bots need to be ready to scale up operations swiftly. Moreover, they must be resilient, capable of withstanding harsh conditions while maintaining their functionality. With careful design, edge computing can make rescue robots more effective than ever. In the face of disaster, these technological marvels can truly be a lifesaver.